Alright, let's get ready for the Unit 7 quiz. So taking a look at this table, I see that we've got the hydrogen ion concentration in standard notation, but let's write it in scientific. That would be 1 times 10 to the minus 4th. And pH will match that. So pH is 4, and pH and pOH always add to 14, so that means the pOH here is 10, which makes this 1 times 10 to the minus 10th for the hydrogen ion concentration, and there's going to be 9 zeros for the standard notation. Since the pH is less than 7, this is an acid. Here we've got a concentration of 0.01, much higher concentration of hydroxide than our first row, so I have a feeling this is going to be a base. pOH would match that exponent in the hydroxide ion concentration. If pOH is 2, the pH is 12. 1 times 10 to the minus 12th, that's 0.00000000000, 11 zeros. This is a base because the pH is above 7. If something's neutral, that's our only hint. The pH is 7, which means this would be 1 times 10 to the minus 7th. 6 zeros, and then a 1 for the standard notation. pOH would also be 7. Hydroxide ion concentration would also be 1 times 10 to the minus 7th. And 6 zeros and a 1. What happens to the pH of an acid when you add water? Well, when you've got a pH of an acid, it's probably close to 0. So when you add water, it goes up until it reaches 7. And for a base, maybe you've got a base where the pH is 14. When you add water to it, it's going to decrease until 7, a pH of 7. Explain why. Well, if you add something with a pH of 7, which is water, the thing that you're adding it to is going to just become more and more dilute. So it's going to become almost all water. Which has the larger hydroxide ion concentration? So which is more basic? So for letter A, that's easy. A base has more hydroxide ions. How about letter B? Something with a pH of 10 or a pH of 4? Well, pH of 10 because it's more basic. And then pOH, I'm going to change this to pH. So 14 minus 8, that's a pH of 6. And 14 minus 5, that's a pH of 9. So something with a pOH of 5 would be more basic. Of the following pairs, which one has the higher hydrogen ion concentration? So which one is more acidic? So for letter A, it's the one that's closest to 0. So pH is 2. 5 minus 2, that's 3. So I'm going to put 3 zeros. Something with a pH of 2 is 1,000 times stronger. It has 1,000 times more hydrogen ions. You can do this in another way too. If we write out in standard notation the concentration of hydrogen ions for a pH of 2 is 0.01, and for a pH of 5 it's 0.0000001. So 0.01 divided by 0.00001 is 1,000. Okay, so you can see why I like the little trick of just doing the subtraction and adding that many zeros after the 1. So here, which one is more acidic? pH of 6 is closer to a pH of 0, and it is 10 times more concentrated than the pH of 7. pH of 4 versus pH of 8. Again, the pH of 4 is closer to 0, so that would have a larger hydrogen ion concentration, and 8 minus 4 is 4, so it would be 10,000 times more hydrogen ions in that pH of 4. Number 5, which pH indicates the highest concentration of hydronium ions? Means the same thing as hydrogen ions. So the answer is pH of 1, the one with the smallest pH. The active ingredient in bleach is sodium hyperchlorite. Show how the hyperchlorite ion, so just the OCl- part, interacts with water. Well, it's acting as a base. That means it will accept a hydrogen. So this will now be HOCl, and it ripped a hydrogen off of the water molecule, so it's leaving that hydroxide in solution. Many fruit drinks contain citric acid, H3C6H7O7. Show how this reacts with water. Well, acids donate, so it's going to give up at least one of its H's to H2O. So it'll be H2C6H7O7 plus H3O plus. Explain how to identify acids and bases based on the Brønsted-Lowry definition. Acids donate hydrogens. Bases accept hydrogens. Show what happens to the following substances when they dissolve in water. What ions do they form? Is it an acid, base, or neutral? And explain why. MgF2, this is ionic. So this is going to break apart into its separate ions. It's going to get pulled apart by the polar water molecules. I don't see any OH minuses or H pluses, so this is going to be neutral. How about H2SO4 though? This is going to donate its hydrogen ions to the solution, and you're going to have that sulfate anion. Since I see H pluses, that should scream to you that this is an acidic solution. And the last one, we've got an ionic base, so it's going to dissociate into its ions, Ca and 2 hydroxide ions. So those hydroxide ions should scream base to you. Alright, as 50 milliliters of a 0.1 molar HCl is added to 100 milliliters of a 0.1 molar NaOH, the pH of the NaOH is going to what? Well, since NaOH is a strong base, let's say the pH starts at 14. As you add an acid to it, it's going to decrease until it gets to 0. It's going to become less basic and more acidic. Number 11, some practice with neutralization equations. Identify the acid, base, salt, and water. Well, I can see in this first one here that we've got a hydroxide, so this is a base. This one starts with an H, so it's an acid. Double displacement reaction. Aluminum is now going to be with the nitrate. So let's check charges. Aluminum's a +3, nitrate's a -1, so that's going to be AlNO3, 3. And we're also making H2O. H is switching places with the Al, so that one is now with the OH. And we're not balanced here. We're going to need NO3, 3, we're going to need a 3 here, and so then we're going to have 6 hydrogens, so we're going to need a 3 there. This is water, and then this is the salt, aluminum nitrate. Alright, next one. What have we got here? NaOH, this must be the base. It's got the hydroxide. This one starts with an A, it's the acid. Na is now going to be with CO3. Na is a +1, CO3 is a -2, so that's Na2CO3. And H is now going to be with OH, H2O. And then it's Na2, so we're going to need a 2 there. 4 hydrogens, we're going to need a 2 there. Here's the water, obviously, and here we've got the salt, sodium carbonate. Number 12, use this neutralization equation or reaction to answer the following questions. Remember to balance it first. So we got to balance this thing. Ca3, 3Ca, PO4, 2, then we need a 6. We've seen this equation a few times. In fact, I think these are the same questions that are in your notes, or very similar. If you've got 4 moles of H3PO4, write out what you know. How many moles of CaOH2 is it going to take to neutralize it? Well, look at the numbers out front. For every 2 moles of H3PO4, you need 3 moles of calcium hydroxide to neutralize. So 4 times 3 divided by 2, you need 6 moles of calcium hydroxide to neutralize that 4 moles of the acid. Okay, this takes you up a step. What if you've got 0.5 liters of a 0.8 molar solution of calcium hydroxide? We're talking about 0.4 moles of calcium hydroxide that we're trying to neutralize here. Again, for every 3 moles of calcium hydroxide, you need 2 moles of H3PO4. 0.4 times 2 divided by 3 comes out to be 0.27 moles of H3PO4. Moles divided by molarity will give you liters. So 0.27 divided by 1.4 equals, I'm going to write it way over here, 0.19 liters of acid, of that 1.4 molar acid. That's how much it will take to neutralize that base. Similarly, but asking a different question at the end, what if you've got 0.04 liters of a 0.1 molar solution of calcium hydroxide? That comes out to be 0.004 moles of calcium hydroxide. For every 3 moles of calcium hydroxide, you need 2 moles of H3PO4 to cancel it out. So we're talking about 0.0027 moles of H3PO4. If that was neutralizing this 0.2 liter sample, again, I just divided these by 1,000 to get these other numbers in liters. That comes out to be a molarity of 0.0135 molar H3PO4. Alright, number 13. Use this reaction below to solve the following calculations. I'm going to rewrite it just so I can, I'm going to rewrite it just so that I can write the information right below it. And I'm switching it around, but it doesn't matter. So NaOH plus H2SO4 makes Na2SO4 plus 2H2O. So we've got some base that we've added to neutralize this mystery sulfuric acid. So let's write what we know. 0.15 liters of a 0.5 molar base neutralized 0.25 liters of this mystery acid. Molarity times liters gives us how many moles of base we needed to add to neutralize. It's a 2-to-1 ratio. For every 2 moles of NaOH, you're neutralizing 1 mole of H2SO4. So there were only half as many moles of acid in there. That comes out to be 0.0375 moles of H2SO4. Divide by the amount, 0.25 liters, and now you know the molarity of your mystery acid, 0.15 molar H2SO4. And the last problem. You want to make this solution and you've got a stock solution. The concentration of the stock solution is 1 times 10 to the minus 1. which is the same as 0.1. So anytime you see that you've got this stock solution, you're making a new solution, this is a dilution question. M1 times V1 equals M2 times V2. We've got a 0.1 molar solution. We don't know how much of it we need yet, but we know we want to make a 0.0001 molar solution, and we want to make 250 milliliters of it. Divide both sides by the 0.1, and V1 comes out to be 0.25 milliliters. So what that means is you're going to take a 250 milliliter flask and you're going to add 0.25 milliliters of that stock solution, that really concentrated stuff. Then you're going to add a bunch of water and you're going to mix it up. And in the end, after you mix it up, your new concentration is 0.0001 molar because you diluted that really concentrated stuff. Alright, good luck studying for the rest of the quiz. I'm going to go